My name is Rupak Ganguly. I work for CenturyLink, and CenturyLink Labs is a 12, 13 engineer group that we started in March. And it was started by Lucas Carlson, the CEO of AppFog, who got bought up by CenturyLink. And we basically wanted to do something that would do brand recognition for CenturyLink and bring them as a cloud provider. And we picked up Docker, which was cutting edge. And while working through Docker, we figured out that it was really, really hard to get into Docker. So there's a command line, and there's a bunch of help for the command line. And then you have a 3-page tutorial, and then you basically have to write your apps on your own. So we set on to a journey of writing Docker management tool that would ease the learning curve for Docker. And basically because we really like Docker and we wanted to grow that ecosystem. So quick about me. I worked in HP Cloud Services till last February for 13 years. Cloud services for 3 years, OpenStack contributor, open source. The biggest contribution was probably the fog provider for HP Cloud services. And I've been a Rubyist since 2009, after I saw the infamous 15-second blog video, like everybody else, I guess. I was .NET architect, .NET architect in the past for HP, and Compaq before that. So I'm going to move on. How many people have actually used Docker? OK. Or at least read about it, heard about it, right? So just a quick recap. This is not about Docker. And again, it's an open platform that came about like a year or so, came out of .cloud, and it's for building, shipping, and running distributed application inside containers. It's a concept where they took the virtualization concept of putting your machine like a zip file inside and running it. It's a concept of taking your application along with its dependencies and then putting it into a so-called container. Well, the cool part is that you can take the container, and as long as you have a Linux-based machine, you could actually ship it, and it is totally portable. So you build it at some place, and then you can run it at any other place which runs Linux and has the Docker daemon running. So Docker Engine is a portable, lightweight runtime packaging tool. It has a CLI which you interact with. And that's where I was mentioning that that's all you get when you start off. And it's a bunch of flags that you need to pass, and you have to basically figure it out. When we started in March, that was the case. The ecosystem has developed a lot. Now we have a Docker hub where people can push their images, just like GitHub, where we share code. Docker hub is where we share images. So you might write an image. Let's say you write a Rails application, like the application you were talking about. You can actually containerize it and put it on Docker Hub. I could pull it down and run it on my machine just like that. I don't have to know anything about it, how to set it up, or what dependencies I need, or what version of Ruby I need, or what version of Rails I need. I don't need to know anything. It's all packaged up, and it just runs. And we'll see how it works tonight. Of course, the advantages are it works on your machine, and it also works anywhere. Ensures repeatability and removes dependency hell. So those are, like, I think, biggest things we developers face every day, and that makes it awesome. So what is Panamax? So we started in March, and we're looking into Docker, and we figured that it needs some more love on top of what it already has. So Panamax is has a UI on top of Docker. And there are a couple of more Docker UIs that came about in the last couple of months. But we are about orchestrating multi-container applications. So just like microservices is a buzzword now, but even before microservices came about, we have been writing distributed applications. And it has been really hard to deploy distributed applications on cloud providers like Amazon or so what Docker allows you to do is create these services as separate containers, and you can deploy them to any machine, multi-clustered nodes, and then you can link them together and run them. Each service being a very self-independent unit. Panamax brings that together in a nice UI where you can drag and drop and create these applications and then run it locally on your box. We just released a plugin architecture for deploying remotely. So till about last week, we had Panamax where you could run everything locally. We got a lot of requests to actually take that same application and deploy to something like Kubernetes or CoreOS. These are two new orchestration engines. Kubernetes from Google, and CoreOS is the new Linux operating system, a lightweight operating system. So we have a plugin architecture that we built so that if you have another orchestration engine or a cloud provider that you would like to deploy, you could easily write a plugin for Panamax, and it would deploy to that. We got a lot of requests for, so currently you can search for your images from Docker Hub, because that's the only registry available. Recently, CoreOS bought Quay.io, which is another public registry. So we also integrated creating private registries for yourself, and you can actually run it yourself for your own private images, and you can use it from Panamax. And last is everything is 100% open source, and it's all out on the web. I'll give out the links. Go out, you can go out and check that out. Pretty much, you'll see that creating containerized apps by Docker is easy, but we make it even easier, and transparently, we get over the hump of going through the CLI and learning all that. But at the same time, we expose enough that we are not creating an abstraction so that you don't learn Docker. We also make it a point that you learn Docker. And then you can take your app. So once you create the application in Panamax, you can save it as a template, which we call an application template, which saves all the links of the different services that you have in the application. And then you can share it on GitHub. So there is a GitHub public template repository that we have. There are a bunch of examples of templates that you can, once you want to start off, you can go to Panamax, you can search, and you can just start and run a template, and you have an application going. And as I said, we just implemented deploying to Kubernetes and CoreOS. Why do developers care? Well, first, it gives immense portability. As I mentioned, we have lots and lots of code that we write, but it's very hard to share the running version of that code easily, and that makes this very enticing. And not only Docker, but with Panamax, you can take the source code and develop locally, and after you develop locally, you can just remotely share it or deploy it and then share it. Loosely coupled architecture is not new. We have been doing this forever. It's just with Docker, it's easier to take each service and independently create them as images and then reuse them. So for instance, if you have a Rails application which uses Sphinx as a search, you can create Sphinx as a service and Rails app as a service. The database can be as a service, and all then three can be linked together. But then once you're running the Sphinx server, you can have another Rails application somewhere running, which can point to that same Sphinx server and reused. That's the whole idea. Collaboration, templates makes it very easy to share and collaborate. I make a template, I give it to somebody else. They can change it, add some more services to it, and we have a new application. Management, our main focus was to somehow get around the whole fact of managing the Docker images. And so Docker has services and it has apps, images. So we just put down a nice UI on top of Docker so that without getting into the terminal, you can just manage the stuff there. Transparency, of course, everything is open source and everything is on GitHub. So how you start, I'll give out the links later. You can just download Panamax. We're still in the process of getting into Brew. I think it shouldn't be that big a URL. It should be brew install Panamax, but it's still getting there. That's how you install it. And then, so I was probably this slide should come later because Panamax is new to most of it, but we added a lot of features, and I'll go over this as we go along. Maybe we should jump to the demo and show you what it looks like. But private registries, remote deployments, performance metrics, service details. We'll come back to this slide. Template marketplace, as I said. So before I get into this, the reason why these two templates are being shown is in September, we did a contest. And we asked people to write templates. And we gave away $100,000 worth of Mac Pro and iPads. And these are some of the templates that people wrote. It's a Locomotive CMS template and a Jenkins multi-slave template. All right, let's get, so I'm going to pull this guy. I have like a 3-monitor setup. It's just all messed up right now, so bear with me. So Panamax, as soon as you install, mention a couple of things. We start a browser session with panamax.local map to the IP address that is internally mapped to the Docker sessions, and we can get into details, but I'm going to quickly go over. There's a lot of stuff I want to show. So you're shown this screen where you have this dashboard, you have applications, you have sources, and I'll get to that, and images, registries and deployment targets. You can see there's a health monitor here, and we use Google's open source C-Advisor image, which actually lets you do performance metrics on your running containers, and we'll go into the details there. So first thing you want to do, so we have 0 applications right now. So you can go search, and this search actually goes out and searches the Docker Hub. And for instance, you could search WordPress, and it would go and search. Let's see, I think we have enough network. OK. 1 second. All right. It's working. OK. Let's see what you can do here. Let me quickly check. All right, that's working. OK. We'll do another try. Where is WordPress? So once you do searches, you also do caching. So we cache the templates and the images that you have on the local. So these are the images, and these are coming from Docker Hub. The ones that says local is, of course, local, and the official are the ones which are on Docker Hub. Trusted is kind of a misnomer. Docker came up with this terminology where if you link your GitHub repo directly to Docker Hub and you do a build, they used to call it trusted. Now they call it something else. So these are the templates that either we or people have created, and you can write some documentation on it. And these are the two images that are using this. So let's go ahead and run it. So in the past week, we just added the deployed target. We'll go over that later. First, we will go do run locally. And you come to a screen where it, of course, tells you that the application ran. And then there are a couple of things happening here. It tries to download the image from Docker Hub and run it. And those are the services that are shown. We present them. We have a capability of actually categorizing them. You can create a category that is outside of Docker. It's just a Panamax thing. We thought, being application developers, that made little sense. And then from here, you see that two services are running. You can click on a service, and you are taken to this service detail page. And as I was mentioning earlier, that we're not trying to make you foreign to Docker. So what you have done is, while you orchestrate your applications through Panamax, we also show you the Docker run command that was used to create it. So you're not bound. We're trying to teach you what we are doing behind the scenes, and it's nothing extraordinary. We're just running the same Docker command. And as you can see, this is just one glimpse of it. There are more complicated flags that you can pass in. But we're trying to educate the user how this service was run and what image is being used, what ports are being opened. And so you can see this -p is so cryptic. So if you can come here, you go to the port section, and now it makes more sense, where you can see that the mapped endpoints from 8080 is so the host port. So Docker has this concept of since it runs in a container, everything is secure, relatively secure, where the port 80, which WordPress exposes, we are trying to expose that as 8080 because there might be other different containers which might have 80 to avoid conflict. So you can see there is a small little help that you can see which tells you 8080 is the host port, 80 is the container port, and the protocol is TCP. And then there is a nice link that you can click that will actually show you the application. So we make it very easy and trust me, if you have used Docker, you realize how easy this is. And then there are some other things that we do. When you create a Docker image, you can actually expose ports in the Docker file itself. And it has been a pain to use other people's containers or images because we don't know what ports are being opened. You actually have to go. Sometimes people don't expose their Docker files. So we actually introspect the image and pick out the ports that are being exposed. Just again, if you notice, this is just a learning process to show you how images are used. We can use volumes. I'll not go into volumes. Volumes is like EBS in our AWS world. You can mount something as a volume and then just use it like a linked data store. And then last, so Docker has a concept where after you run this Docker command, you can actually override what is being running by putting a run command at the end. So you can actually enter it here. So we give that option as well. You can enter that command here, and it will run that. Sometimes for debugging purposes, or you want to open a shell, you can bash into one of the Docker containers, and you would just say bin bash here, and it will run the container again with bin bash command, and it will override whatever command was originally running. Most importantly is the service links. It's very, very hard to figure out the links between Docker containers when they're running, because how they are built by Docker. Docker uses this environmental variable trick, and it injects the parent container, or the child container's info into the parent container so it can communicate. So if, like, for instance, my MySQL guy has password and the host port that it exposes, how would the WordPress container know about it or connect to it? So it would, when you link them, it would inject environmental variables that will actually expose those ports. So it's very confusing. So this opens up that and visually illustrates what the linkages are. If we go back and if I go to the DB, there's no service here, and you'll see things like that. Of course, you wouldn't put the password here, but remember, this is just a template that you're running locally for testing. When you deploy, and I'll show you later, you can override all of these environmental variables while deploying, and that just directly goes into the service.
Can I ask a couple
Sure.
questions? I'm like utterly lost. You downloaded a Docker container.
Sure. Well, an image.
When you downloaded a Docker container, did that include an entire VM, an OS, all of Rails, all the gems, all your application?
OK. So
and secondly, once you download that container and you're running it on your laptop, what do I see in PS? Do I see a single process called Docker and everything's running inside that? Or do I see, say, 400 processes running all the pieces?
OK. So I'll answer your first question. So first question, partly yes, partly no. You don't really get a VM per se. What you get is, so Docker, you get a Docker daemon. So going from basics, so you have an Ubuntu machine or a Mac machine. You install Docker, and then you get a Docker daemon. So you do ps -ef, you'll see Docker running. That's one process. Now,
and all of the application is running somehow
inside, right? So here's how it, so the services, so these are called services in terms of
they're LXC containers, correct?
Yes. So LXC containers, they are services which actually live as services on the box. And if you run like systemd and you check, you will see those services running. But they're all encapsulated within the Docker ecosystem, and Docker can manage them. That's what it does. You download images. Images is like class, and containers is like object. So it just,
to me.
OK.
So you downloaded your Docker container. It took 3 seconds. So that was how many gigabytes?
It depends. Most of my stuff was cached. It just depends on your network. It could be 300 MB for a WordPress container.
How big is a Docker container?
It just depends. How big is your code?
Okay,
Exactly.
So is it as big as an operating system?
No. No. It doesn't have anything except your code. That's it.
So the difference
operating
the difference between an LXC container and a virtual machine is you don't have multiple. Sure, I'll say this. The difference between, more or less, the difference between an LXC container, which is basically Linux's version of shroot jails that you used to have in Unix land, except it's more encompassed, BSD, yes. So basically, it's just the app code, like it's just Postgres and the support stuff. But the trick is they act like a bundle, and the operating system knows how to deal with that, and Docker helps you manage it. You actually don't need Docker to do this stuff, but Docker is a set of utilities that makes it easier.
Correct. So, and that's where the difference between a VM and a container containerization comes, where VM actually has everything. Docker just reuses all those underlying services.
But they're jailed from each other. Like
So
one
there's just an
container can
assumption
come.
that Postgres was already there?
No, you can.
No. So here, so just like any other software, you apt-get Postgres, assuming that somewhere there is a place where I can download Postgres. It's the same thing. Docker Hub is a repository of all these images that people have submitted. And Postgres is one of them, or MySQL is one of them, or WordPress is one of them. And you can do it too yourself, or you can go and look. So if I go here, I mean, I think this will be much better. Oh, actually, let's do this. I'm already on Docker Hub. So this is Docker Hub, right? I mean, just another. So here you can go and, like, let's say I'll search for, give me your, okay, yeah. So you can see, I mean, there is like ton of, and it's just like GitHub. I mean, you go and search for a Rails sample project, there'll be like tons of them, and you can go and look at the file. So let's say,
Rails good. That's always good.
There you go. Okay.
Learn how not to do it.
The good ones, the good images are the ones who actually give you documentation what they're trying to do, and most importantly, they have a Docker file. The Docker file actually tells you what actually does. So to answer your question, if you look, it's doing a bunch of stuff, and at the end it's just saying, okay, just put, so that add script start is just putting stuff into the start folder, and then it's doing some user setting an environment variable and command start, and start is probably a script which we can see if you go to their source page, and it probably just starts Rails. So you'll have to probably dig into some of the Docker images and see how it kind of works, but that's what it is. I mean, that's the difference. I can talk to you later. Let me get through this real quick, if you don't mind. Oh, sorry, we were in the demo.
I was going to add, if
go ahead.
anyone's still confused on that right now, if you understand a virtual machine where you have a complete copy of the operating system running and it's isolated from the other things, LXC containers, you can have multiples running on the same machine, and they're isolated from each other. They're sandboxed.
They're running in the same operating system. They're using the same kernel. They're using all the same processes.
Exactly.
But all of the installed applications, Postgres, so on and so forth, are isolated from each other. So if you start up a Postgres image, it's got Postgres installed in it. And so when you download it, you're downloading all the Postgres stuff. And when you start up a Rails one, it's got all the Rails stuff in it. But they don't see each other. You can't just log into Postgres from one and vice versa.
So these are the containers, just if you're curious. So they run like that. They're containers. They're like sandbox, as the gentleman said. And there's a concept of C groups in Linux that they use to do sandbox all the things that this container can do. Their metrics are separate. So their file access, everything is separate. They're all sandboxed. And here you can see the app that I just ran is running as this image. This is the image. That's the last command it ran. It's been up for whatever time, and then it shows what ports it exposed, and we saw that it was exposing 8080. And these three containers is Panamax. Panamax in itself is a containerized app. So we have a UI layer, we have an API container, and cAdvisor is the Google's regular cAdvisor, which we just integrate into to show performance metrics. Sorry, to go back. Any question? And then with Docker, you can also inspect each container, and it will show you a lot more data. And the environment variables that I talked about, we also expose that. So that, as I said, we want you to learn and see what's behind the scenes. So you'll see this is just the dump of Docker inspect. And you can see what is happening. That is export ports. And maybe I should show the other one, which has the environment variables. 1 second. You see how Docker would actually expose environment variables where into and inject it when you link the WP and the DB container together. It will actually inject this automatically. And the convention is the alias of the container underscore the environmental variable that you passed. So if you pass password, it will be DB underscore, because DB is the alias of my MySQL container. As I said, there is a lot going on behind the scenes. That's where I think we wanted to make it easier. I don't know why this is not showing. We actually show the activity log as well. Okay, where was I in my thing? All right. Do we want to go into that, or all right, might as well. So actually, let me show you the template workflow as well. So running an application now, let's actually hit the box. So you can see the WordPress that I just ran, and it showed the port. That's where WordPress is running, and this is live. So that's how easy it was to create a WordPress application. They were all containerized. They're running locally, and you can run it. Now the next thing was, well, okay, I have it. I want to actually share it with my friend. So you can say save as template, and there is a screen that got skipped because I already have my GitHub token. If you are coming for the first time, it will actually tell you that, create a personal access token in GitHub and put it in there so that we have access to your repo, and we just write to your repo, whichever repo you pick. So you can actually pick, it will pick all the repos that you have access to. And then let me see, pick one of my test templates repos, and then we can say and you can give some description. You can describe and you can keep some you can put some keywords that we can use later for running the app. Oh, searching the app, sorry. Oh yeah, sorry. There is no plus. Oh, there is, yeah. So Apple shift. There you go. Maybe that's too big. Is that better? Yeah. Sorry. Okay. So here you can put some template documentation and supports Markdown, and then before you publish your template, you could look at a preview. Sorry about the size, but that's I don't know if you have heard about Fig. Fig came out, and Docker actually bought Fig recently. It's from a company called Orchard. Initially, they had this template, or not template really, YAML file format that you could use to build applications. We're heavily influenced by their format, but we added stuff like categories, and we later on went in and added a bunch of stuff. But that's how the template file looks like. It's YAML, it's English. You can read it, you can understand it, you just clearly, very clearly. So there is no magic going on here. That's the template file that will actually get published to your GitHub repo. And so that's the template that we saved, and you see the whole template file gets saved, and you can basically just take this, just a file in GitHub, you can just share it with your friend, and then they can import it. How do they import it? So we don't use the term import per se, but let's say this is your friend's machine. You can search for Ruby or whatever the name of the template is, and you can see that the template was picked up. And then as easy as it is, you can just run it from here. Again, either locally or deploy to target. I'm going to quickly show you the remote. Well, I wanted to, OK. Let's see.
It shows how you would actually build a new image.
I really didn't plan on that. I could do it after, if you don't mind. Just really wanted to show the remote deployment. What I have here is, let's see, Drupal activity. OK. Going back, sorry. So we have a template for Drupal. We can take that. OK, before I go there, to do remote deployments, you have to create deployment targets. And I've already set up deployment targets for one cluster on GCE, which is running CoreOS and Fleet. Fleet is an orchestrator. And another cluster on GCE, which is running Kubernetes cluster.
What is GCE?
GCE is the Google Compute Engine. And they're already set up. That's the URL that you can, that's the endpoint. So having done that, we can run Drupal. And we can say deploy to target. And before I do that, I'm going to bring up this.
Validating this SSL certificates or not?
There is.
So they're actually on the IP address.
Yeah. So OK, let me show you that. Yeah. So real quick. So the process is not that, the token. So that's the token that you so you go to your where you set up the cluster, you install our agent, and I'm going to go over the architecture real quick. When you install the agent, it spits out a key for you, and you're going to take that key and you're going to use it here. So you are the only one who's communicating back. So it's tied in there, and the certs are installed. So going back here, deploy to target, I want to have this up. Let's see where it is. So that's so here's GCE or Google Compute Engine with my 3-node cluster for Kubernetes. Oh, sorry, CoreOS, and I think there is one here. Well, I lost all my windows. One second. OK, yeah, that's the other one with Kubernetes. So we'll deploy the Drupal app on the CoreOS cluster. These are 3 clusters here. And I'm going to actually run. Let me see if it's already running or not. So I'm actually logged into that one of the boxes here. And it will show us the services. And it will also give you an idea how the services look like. If I can connect. OK, there you go. First thing is Fleet is an orchestrator that lets you deploy services in a cluster. And let's do, just to show, it tells you there are 3 machines in the cluster that it recognizes. And then list units would show the units that are running. So these are the services. Fleet calls it units. or system decalls it units. Okay, so now here, just a very small screen to keep everything together. But I wanted to have this guy, not this guy, this guy running here as well. So once you are in, so you can select either one of the targets that you want to deploy to. And you come to this deployment screen where, when I was mentioning earlier, when you ran it locally, there was some environment variables that had passwords and stuff. Now you can override them here. And it will override the template remains the same, but it just updates those values. And you can add more. And then I want to do a 3-count scale deploy for Drupal. So I can pick that, mark it as 3, and deploy to target. And I'm brought back to a screen where it says these 3 services are running. If I go back to my machine, you should see 3 services running. I don't know if you can see it or not. 1 second. And as you were mentioning, start free is basically saying that I don't have the image yet, so I'm downloading it. But the MySQL service, it's already running because the image was there. It's just cached under Docker images. So those 3 guys are just getting, and probably the network is slow, so it might take a while. But if you take my word for it, you can see the IP addresses here. Those are deployed to 3 different boxes, and MySQL is just sharing one of the nodes. So this should come up. Well, we can probably hit it now. This, okay.
What if those services weren't there? For example, you said MySQL was already running. What if it wasn't?
If it wasn't, it would just download it. Like we saw our other guys getting
Downloaded from where?
From Docker Hub or any registry that you have the image on. So the whole concept is the code is bundled into something called an image. The image is kept in some repository at some known address. And then when you build your service, you reference that. So when you run it, it says, oh, I need this service. So it will look at that URL, it will go there, and it will download it. And then it run it.
So I think that's what was confusing Randy and also me.
Yeah, it's like apt-get or bundler or anything that auto-downloads.
Correct.
Dependencies. Yeah, Vagrant, all that.
Or anything, yeah. 146. Where is it running? Hold on.
And Git or Docker Hub offers private repository.
118, 104.
Did you hear the question?
Sorry. My bad.
Does Docker Hub or Git still offer private registries?
Yes, they do. Yes, they do. They offer one for free, and then QA does too. They have private, and then, as I said, you could actually run your own private registry. It's very simple. There's one container. You just run it under Docker, and then you can just use it. So you can do that. Let me see if I can get this. Well, I'll just keep going. Just take my word for it. Drupal runs.
We're actually running on time. So.
Yeah, we are? Okay. Okay. I'll wrap up. Yeah, I didn't realize. Okay. I'll wrap up. Just quick, as I said, we saw Panamax runs has 3 containers. And you can see one side we hook up to GitHub for saving templates. Other side we hook up to Docker Hub to do image search. and applications run within Panamax under Docker. And then Panamax is made up of 3 containers: UI, API, and C advisor. That's the agent adapter architecture. You can write your own adapters for your deployment models. UI talks to API. API goes over the web SSL to the agent that is installed on the target, and then it talks to an adapter, and it can go out to any one of these. Atomic, Project Atomic is one of the Kubernetes, Mesosphere, and CoreOS. I will talk to you about the build images, but that's how when you build images, they show up on Docker Hub, and all of our images are actually available on Docker Hub. So you can actually go and download Panamax UI, Panamax API, can actually run it on your own. This is something that I wanted to explain but couldn't get to, but that's the Docker run command, and I wanted to explain how it works. But those are the API. That's how you run it. We make it just simple by giving a nice UI on top of it. We are a very agile team. We received a lot of feedback, like support for CoreOS clusters. People wanted to deploy on CoreOS clusters, so that we just deployed that. There was like, so if you have any feedback or you wanted to know anything about Panamax, please feel free to come back and give us some feedback. And the main reason why I wanted to come here and give the talk was we are a bunch of Rubyists who love what we do, and I would invite you to come and look at our source code, give pull requests, make suggestions. We would love to have insights from you. Everything is up on GitHub under CenturyLink, and that's the bunch of guys. And there's some of the people in the industry who have been, and the last part is we will be at RubyCont. One of my colleagues, Laura Frank, will be presenting, and it will be more about Ruby in writing applications, Ruby applications with Docker. It will not be a Docker presentation. So if you get a chance and if you're going, hit us up and we can talk more about it. I will be there too. And that's it. I will post the slides on the group, Meetup group page. And you can, if you have any questions, any ending comments, I know I ran out of time, sorry about that. I would like to take any questions now or later. I can hang out after this too. So
does Panamax focus mainly on managing your interaction with the repository and doing remote deployments and all that? Or that much is clear.
Sure.
Does it also help you, like I have a Rails app on my machine.
Right.
Can I push a button to make a Docker image?
Okay. No. So that part is like I have an idea. I know how to write code. Can I push a button and make it a Rails app, right? It's like that because creating a Docker file, as easy as it is, like just few commands to create a Docker file and it builds it. There is a process to the madness, and there is some stuff that you have to probably go through. You have to probably tweak your Rails application a little bit, not the application part of it, just the setup or the running part of it, right? The execution part of it to fit that model. But the Docker building the images part was not that long process, and it's not that complicated as such. Once you start doing it, you will see that it's not that much. So we focused on a broader scale of saying, well, you have a Docker image, you have a single Docker image. Most of the people start with a single Docker image. They will just build it as a, but how do you actually create distributed applications with multiple services? That's how we started. And then we were really bogged down with Docker running, learning Docker. So we made it simple for you to come and create when you're starting off. And then while you see the examples and the Docker run commands and the inspect command, you learn from them. And then you go ahead and do your thing if you are if you get comfortable at the CLI. So it was like more of a thing. We wanted to just bring the ecosystem up. And now from there, the next step, as people asked, was, OK, fine, I have things running locally. Now what? So they wanted to deploy it. So that was the next part we did. So go ahead.
Yeah, so I guess it's kind of the same. If you had 3 sentences to describe what it is that your Panamax is providing to the Docker community, like pretty pertinent, quick,
sure.
What would they be? OK,
one is intuitive user interface and easy path to learning Docker itself, right? Second, creating multi-container applications from image management, service management, running it locally, and then deploying it. That's what it is. Anybody else? Yeah, go ahead.
Yes, so when you deployed there and you mentioned that the MySQL was cached already on the remote machine, what was it caching? Like some system level packages, or like is the stuff in this Docker hub like actual MySQL binaries that it's going to get?
Right. So when I said cache, probably cache was not the right word. What it does is when you ask for a service to run, it basically looks for that image somewhere. So when it brings it down, right? So when I said cache, I meant the image was already on the machine. And you can look at it. I can show you, I think. So if you can see. So this guy, this is a different image, but they just sit as images, and there is a whole file system that caches the image as a entity, and they're referenced by a name. You can tag them, you can version them, and like the gentleman was asking, you can build images from code, and then you can deploy them to any repository you want.
Okay, so are the images like a set of commands that are running? Are the images like a set of commands that are running, or are they actually just like a big blob of executable code that like you get and then Docker runs them as services and just keeps them running, and you just pass in your environment variables?
Right. So
just does stuff. Yeah.
So CoreOS is a operating system where it implements copy on write. So when you build the images, it builds the images by layers. So if you have 5 different commands, it would run the command. So let's say your first command was apt-get something, some library. So to just run that while building the image, not while execution. This is the first step. You're building your image. So you run this bunch of commands that gets your source code into the image. So to run the command, and it will create a layer, and it will build upon the layer, and you have the final image. Once you have the image, Docker just runs it. It's just like saying, well, I just resurrected the thing that was running on your machine on this process, and it just everything, the process inside just wakes up and just runs, just like that. I'm probably not the best person to get into the details, but there are people in Docker community who have written articles that you can look into, and I can point it to them, to you as well.
Cool, thanks.
Yeah, sure.
One last question.
Yeah.
You showed some of Panamax built-in targets for deployment. Sure. I know Amazon is building one through their OpsWorks. I know Heroku is working on. Are you planning, or do you support any of these targets?
Okay, very good question. So the reason why we built 2, so that we could with one you can't come up with an interface. You need at least 2 to kind of figure out what your end interface is. So we did 2. By doing 2, we kind of sort of have an interface. This is like last week we released this. But the idea is it's all open source. It's an adapter model. It's a plugin architecture. We would encourage people to write their own adapters for their own providers, because they know more about their. So it would be too much for our 12 guys to go and figure out. So we had to actually learn Kubernetes upside down. CoreOS we already knew. But then let's say if you have to do AWS is more common, but then if I have to do something like Mesosphere, which is a totally different orchestration engine, we don't want to be bottlenecks in the development process. We want those guys to come up and write their adapters. Really simple. Anything else?
Cool. Yeah, that was great.
This video has been sponsored by Rieta Incorporated. Learn more today at rietta.com.